Hello everyone, it's me again, it's Suze Shardlow from Redis. I'm the Developer Community Manager here. Thank you for joining me today. Today is the last stream in RU101 Live. I can't believe how fast it's gone. And also I can't believe how much I've learned since the beginning. I was quite scared actually about doing these streams and learning RU101 in public, but it all turned out okay. And it's quite strange to look back over the past few weeks to think about all the things that I now know that I didn't know at the beginning. So yeah, you can check out all the recordings of the past few weeks on YouTube. We'll put the link up there for you to click on. But yeah, this is week 4, but because we're programmers, we started at week 0. So this is actually the 5th week of me learning RU101 in public with my colleague Justin. And yeah, we've come to the end. So we're going to be looking at geospatial today. We'll also have a look at the week 5 homework and also the final exam that's allocated to week 6 in the course at Redis University. If you missed out on taking this course with me this October and slightly into November, then don't worry, this course runs all the time. So you can sign up now for the next cohort, and that I think is in its 2nd or 3rd week. So that's going on for another good 3 weeks. But all the content in that is exactly the same as what we've done. So the videos that we've already recorded hopefully will be useful to you. So yeah, check that out, and please do enroll at university.redis.com if you want to take RU101 Introduction to Redis Data Structures. If you want to keep in touch with us as well in between, if you really miss me and Justin, and like, why wouldn't you? Please come and join us on Discord. We hang out there Monday to Friday. So yeah, please come to Discord and have a chat with us there. So like I said, what we're coming today is Geospatial, week 5 homework and the final exam. I'm going to bring Justin in now. Hi, Justin.
Good morning, good afternoon, and good evening.
Good evening. Yeah, how are you?
Doing really good. It's morning for me, so I've had my gigantic cup of coffee, so I'm ready to go.
Yeah, you've already played the Hunt the Cat today as well, so that's all good, isn't it? Cool. Okay, I'm going to hand over to you then. You're going to talk to us about geospatial.
Awesome. All right, so geospatial is it's an object that stores longitudinal and latitudinal coordinates, so XY coordinates for our globe. If you have a chance, check out our geospatial video on YouTube, our explainer. It's kind of fun. And I go over all the commands there, and we kind of run around in Yosemite. But for now, we're going to be basically running around another region of the United States. But basically, we need a way to store and retrieve and manipulate longitudinal and latitudinal coordinates within a database to encode it quickly and decode it quickly and pull it out quickly and update it quickly, because Redis loves that. So we have something called a Geo Hash. Now, Geo Hash isn't only from Redis. It is a standard that has been agreed upon. But Redis really ran with it and created something really amazing. So a Geo Hash is a combination of the longitude and the latitude, and it's converted to a string numerical combination called a hash. And it's in such a format, it's called a Geo Hash. And you can actually look up Geo Hashes within different websites, and it'll show you the specific location where you're at. So instead of having a longitude latitude pair, which could be each up to 20 integers each, you have it in a compact, nice little like 7, 8, 9, 10 character long hash. So that's what we use. The fun thing is, because Redis loves to be fast and compact, they actually convert this hash into a 52-digit number. So here we go. We have latitude and longitude pair, convert it to a hash, and then we convert it to a longitude-latitude number, and we use that number as a score to actually store that value in a sorted set. And let's remember, a sorted set is a unique group or collection of values that are ordered by an associated score. So refer to our previous videos if you want to brush up on that. But all of our geospatial objects, which are the latitude, the longitude that has been hashed, are all stored in a sorted set in the end. So not only do we have new geospatial commands that we're going to learn today, but we could also use our sorted set commands. So this is kind of nice. It builds off of what we've already learned. So what can we do with these hashes, these geo hashes? Well, a lot. We can find the distance between 2 points. I mean, that's kind of like the basic request of any kind of mapping system. It crows, excuse me, as a crow flies, of course. So the direct line of between A and B, not any kind of like driving directions, because that's up to the application to create. We can also find within our sorted set how many points are within X units of measure from us. So let's say like I'm pulling up my phone and I use Google Maps to say how many coffee shops are within 5 miles of me. I'm going to go for a walk this morning. That's the power of geohashing, geospatial indexing. They basically said, oh, well, we have like 3 coffee shops you can walk to, and then checks within that radius. So basically it compares your location or any given location to a set of other locations and gives you information as far as how close or far you are. So let's actually see that in practice. I was going to add a couple points into our shared Redis insight so we can start playing with them. So here we go. Does that look okay?
Let's see. Yeah.
Okay, cool. So the command that we're going to be starting with is called geo add. Now geo add, as we can see with the hints, requires a key and then a longitude, latitude, and a member. So remember that this is like a sorted set. So we're going to add items. We're going to add items to this sorted set. Then it's going to contain a score and a member name. So something that you can actually use as a name. And this could be like a proper name, or it could be another key name that you can use to look up somewhere else. So I'm going to use geo add. And for the key, let's go with the idea that I keep like a geospatial index of all the favorite cities that I like, that I have visited within each state, be it Washington, Iowa, Florida, Louisiana, wherever. But let's say that for this key, I'm going to have location, Washington, visited. And this will just be just a huge geospatial object that contains all of the cities that I've visited. And I'm going to include the longitude and latitude. So the longitude, and I always remember this one because it's a longer number. It's the only thing I can remember.
Good tip.
Yeah. So it's that's going to be the longitude, and the latitude is going to be 4765 and 28443. So, and then for member, I'm just going to use the name of the city. So this is actually the location for Seattle, Washington. I could change this to an ID of a key, so city 48, something like that. It's whatever works for you in your application. So, all right, I just added my Seattle geospatial coordinate pair to the key location Washington visited. And it gives me an integer 1, which is the total number of objects I've added to my geospatial index. So I was saying how we hash these coordinates pairs into an actual hash value of strings of letters and numbers. So let's actually use the geo hash command. So geo hash, and this is to verify that we actually have something in there. So it's going to ask for the key. So I'm going to add location, Washington, visited. And then I'm just going to add the member name, so Seattle. And there we go. This right here is going to be my geo hash. And that's going to be a string value that I can add to any kind of mapping website, and it'll actually tell me, you know, oh, this is exactly where it is. So you see this right here is much more compact than this right here. So now I also want to check out, you know, this is okay, but I want to know the position. Say I want to look up what is the coordinate value of Seattle now that I have, you know, this geospatial object. I'll use the command geopause. It returns longitude and latitude of members of a geospatial index. So geopause, location, Washington, visited, Seattle. What it's going to do is it's going to take this hash that we just created and decode it back into latitude and longitude. And there we go. So you see, we store that data in there, but it can pull it back out. And that just makes it very compact and very fast for Redis, because now it's a sorted set. Okay, so that's just one location. It's not a lot of fun if we just have one location. So I'm going to actually add multiple locations, a whole bunch. And this is going to be included in a cheat sheet that I have provided that you should see shared soon. So go ahead and go and follow along with that if you want to run this afterwards on your own Redis Insight or locally. All right, so I just added a whole bunch, and you'll see that it's 24 total. These are 24 different cities that I visited in Washington that I thought were really cool. And now let's actually start playing with it. Now I see that there's a city called Olalla. So that I kind of grew up next to that city. I want to find the distance between Seattle and Olalla. Now those two cities are located within our geospatial index. So I'm going to use the geodist command. Now, all of these commands that I'm running assume that you're performing actions on cities that are within one geospatial index. One thing to note that's different from other sorted set commands is that when you run like geodistance or ones that we'll see soon like Geo Radius or Geo Search, they all need you to operate within one single key. So I know there's inter and union and diff with sorted sets, and you can run those, we'll see that later, on geospatial indexes, but you really have to be very careful as far as what you're getting back. So geodistance, I'll add location, Washington visited as my key. And then I'll just add the two values, so Seattle and Olalla. And there we go. So that gave me 29,251. I don't know what units that is in by default, but I noticed that I'm supposed to enter a unit. So we can do 4 different units. M for meters, MI for miles, and then KM for kilometers, and FT for feet. But I know the distance between Seattle and Olalla is not, you wouldn't want to measure it in feet. So I'll use MI for miles.
And also in the homework, you'll notice there are some questions that say, find the distance between these two places. Logic there. So you know that the data set is based on the Redis games, and the Redis games are taking place in Tokyo. So is it likely that two places in Tokyo, okay, it's a fictional set of games, but still, is it likely that two places in Tokyo are going to be 8,000 kilometers apart? Probably not. So you can probably eliminate a few things before you even go to put that command in. And I think that's quite useful for just any programming, to kind of have some idea of the result that you're going to expect, I think. So, doing the homework.
I believe that falls under the smells test. When I first saw that value, 29,251, like, I've taken a ferry and I've driven across the Puget Sound to actually get from Olalla to Seattle. I'm like, that's a big number. So yeah, you have to think of the different units of measurement. So cool. Now we see that our geospatial index is actually running, and I can actually run some interesting information. As the crow flies, so in a straight line, From Seattle to Olalla, it takes 18.17 and change miles, which I can verify. So that's GeoDis, and I can run this on different locations. So let's change that from Seattle. Let's do one of those beautiful places, Cape Disappointment.
I've been there many times.
Oh, absolutely gorgeous. My friends were married there. It was so beautiful. And then let's check out another location. Let's go to Klickitat. Klickitat is right on eastern Washington, so it's nice and dry. It's farm country. It's very beautiful. Okay, so from Cape Disappointment to Klickitat, it's 143 miles, and I can verify that. I've also done a very similar drive, and cool. So now that we know that it absolutely works, so that's cool. We can just check distances between 2 points as much as we want, but now let's start getting more interesting information. Let's say that I'm in a certain city or a certain latitude and longitude that I pull off my phone, and I want to find what's around me within like 50 miles. I don't want to do a huge day trip. I just want to take like maybe an hour, 45 minutes, depending on how fast you drive, to a city and check it out. So to find out what cities are around us, we're going to use the Geo Radius command. And the Geo Radius command takes a bit of information from you, but you'll find that this is really useful for getting information back to you that you specifically want, like distance or locations, things like that. So Geo Radius, I'm going to use the key as always, location, Washington, visited. And I'm going to start with a longitude and a latitude of where I am right now. So let's say I'll still use Seattle. Let's say I'm right in the middle of downtown Seattle, so I'm going to add the latitude and longitude. And I want to find out what's within 50 miles, 50 space MI. And there we go. So this is going to tell me what cities are near me. We have Skokomish, Luluwap, Hamahama, Olalla, Dos Wallops, of course Seattle because we're right there, and Poo-Poo Point, which is a great hike. So this information is helpful, but I want more information. So I want to know like where these cities are or how far I am. So you'll notice here we have different options with chord, with dist, with hash, and we can actually employ these at the end here. So let's look up with chord, and this is going to return all of the coordinates. So in Skokomish, this is going to be the longitude, and this is going to be the latitude. And there we go. So we can also do, instead of with chord, I can do with dist, which will give me the distances. And here are all the distances. And I do believe, since I use the MI as a unit of measure for the radius, the distance also spits back MI, so miles. So Skokomish is 44, Luluwap is 38, Hamahama is 34. These are all correct. Now, again, keep in mind, this is not mapping. This isn't telling us how to drive there or how long it's going to take to ride our bikes there. This is a straight line. I can verify based off of my memory that these are all actually very far. You have to go across 2 different waterways to get there. So it's worth thinking about. So, and then let's see here, what can we do? We can also limit how many we want. So we have with dist, and then we can also do count. Let's just say we want 3 instead. So I'll get 3, and those are going to be the closest. Seattle, of course, is the closest because we're there. And then Olalla and Poo-Poo Point are both really, really close, within 20 miles. So it's actually really worth checking out. These are some really tightly packed commands that have a lot of different informations. You can store them, and you can store the distance of what you get back into a different object. You can sort ascending or descending, so you can get the farthest within your radius or the closest within your radius. A lot of different things here. So now that is Geo Radius, and we're working with Geo Radius within RU101. But due to the nature of software, we get updates and we get upgrades. So we actually have a new command that's in 6.2, and it's Geo Search. So I'm going to actually stop sharing this, and I'm going to show you something else. And you won't be able to run this on your Redis Insight if you're running 6.0.2, but you will be able to run this if you're running 6.2 locally. Wrong one. Let's do. Here we go. All right, so this is a beautiful map of Washington State. So what we've been doing with our Geo Radius has been we've been just using circles, right? So based off of my geography, we've been basically running Geo Radius for 50 miles around Seattle. That's right there. So from here to here is 50 miles. From the center on the outwards is 50 miles. Now this is cool, but again, say you want to get coffee and you're in Seattle and you only want to drive 20 miles. I don't want to take a ferry and then drive another 10 or 15 miles across a couple different waterways or onto an island to get coffee. Sounds like a great day to spend, but I just want to go, up or down the street. So instead of creating a Geo Radius search like we have here, we actually can create a Geosearch with a predefined box, which is much more useful. So I can dictate what my search area is going to be with a width and a height, X and Y coordinates. So if I want to find, all the cities within Puget Sound that are on my list, this is the Puget Sound right here. I would create a command that uses these coordinates, these XY coordinates from the center here. Or if I'm traveling to Eastern Washington along the 90 and I want to find a great lunch, I would right here create a search parameter where I create a box around the 90 as I go over to Eastern Washington and I look up all the great hamburgers there. Kind of make sense?
Yeah.
Yeah, cool. Yeah, this is a kind of a newer one, but it's really fun. You can create these custom shapes. Like if I want to find, all the different great parks that we have in the peninsula of Washington, I'll just create a box right around. Want to include Nia Bay. Let's not include Shelton. It's right here. So I can search for all parks within this specific area. This is more powerful than, say, let's change the color here to just kind of make it illustrative. If we use a circle, just the standard radius, it's not going to give me everything that I want to see necessarily. It's gonna give us unpredictable results because sometimes, again, if I was searching in Seattle for coffee, it might give us something on this side over here. So
you'd have to go for a swim. It depends how desperate you are for coffee, though, doesn't it?
Exactly. I mean, good coffee is worth swimming in the Puget Sound for, but yeah, not every day. So let's actually run one of the Geosearch commands. Here, I think
the other thing is as well is that the roads aren't straight, are they? Yes, in American cities you do operate on the grid system a lot of the time, but yeah, if the roads aren't straight, then what's the point of measuring the radius?
Exactly.
50 miles on one road isn't the same as 50 miles on another, is it? So yeah.
So I have sorry, I was using that to check. I have my local instance of Redis up here, and I should have the same information. I'm using zcard. Do you remember what zcard does?
It measures the card. It tells you the cardinality, which is the number of items in the sorted set.
Absolutely, yeah. So I'm going to run zcard on location Washington visited, and I have 25. So that's great. So I know that we have 25 on up in our Redis Insight. This is just a copy of that data. It's not the actual data. But I'm using zcard or another sorted set command just to verify that I actually have it in there. So now let's use a Geo Search command, because again, I'm using 6.2 locally. I'm going to call location Washington visited. Now you notice that we have from member or from lom lat. We can actually ask Redis to say, hey, use one of our predefined members of our geospatial index as the starting point, or we can just give a longitude and latitude. And this is nice. We can also do that of Geo Radius. Don't exactly have enough time to show all of the powers of Geo Radius. We have Geo Radius, where we feed them a longitude or latitude. And we have Geo Radius by member. So we can just say, hey, Redis, tell me what's within 50 miles of the member Seattle, or the member Dos Wallops, or the member Queets, or Quilcene. All these different cities it already knows about. So it gives us a little bit of a speed up, so I don't have to memorize longitude and latitude. So let's do from member and then Seattle. And I just want to show that we'll get the same information by radius, 50 miles. Okay, so these are the exact same cities that I got by calling the Geo Radius command. So we know that that works. And then I can still use the with chord option. So I'm still getting the right coordinates from all the different cities. So it replaces it one-to-one in that respect. So let me clear that out. But where we really start to shine is that when we can start drawing boxes. Now, if you're curious, we can't yet draw polygons, but that is something that we could definitely work on later on, because polygons give you much more of a like a sort of a fenced-in area of exactly what you want. But with Geosearch, let's do the same thing: location, Washington, visited, and then let's do from member, because it's just easier. Seattle. And instead of by radius, I'm going to do by box. We're just going to draw a box. And I want the box to be 25 miles wide and 150 miles tall. Now, this is going to calculate imaginary box, 25 miles wide, 150 miles tall. And it's gonna calculate the Seattle coordinates as the center point. So that's really nice. We don't actually have to do any of the geometry on that. And then I'll use miles as the measurement, and let's do width dist. And let's see what we get. Okay, so we actually have 3 different cities within our boundary box. We have Olalla, which we know is 18 miles. Seattle, which is counted because it's in there, and then Chuckanut. We actually haven't seen Chuckanut in our previous radius checks, because now this shows us that our box has been heightened. Our box is taller, so it's grabbing more from the lower ends and the top ends. And Chuckanut, if I remember, is a small town way north near the border of Canada, so it's very pretty. So now we get different values based off of what we define for our box. So let's say we have 100 wide, 150 tall. So our box is getting bigger. It's going to capture more of what's east and west of us. And there we go. We're going to get, oh, wow. So now we get Obstruction Island, which is always in the way. And we got Hama Hama, Dos Wallops, Poo Poo Point, and Chuckanut Still, Deception Pass, which is very deceiving. You think it'd be beautiful, but you never know. So yeah, boxes are really powerful. Never thought in my career I'd be super excited about boxes, but this is really great if you're in locations that are going to be blocked by waterways. So just harping on like my locations in Washington State, there's a lot of water, and you might not always want to take like a ferry to go from point A to point B. In Bay Area, so right now I live in Oakland, I am roughly 3 or 4 miles away from San Francisco, but there's a big bay in the way. So there's only a couple ways to get there, a couple bridges, or a foot ferry. So I don't always want to go to San Francisco to get coffee or delicious sushi. Sometimes I just want to eat locally. So I would define a box around me rather than a circle, so I don't capture all of those areas. So that's geospatial in a nutshell. I kind of really like geospatial because I love maps and I love looking at areas. If I ever go on vacation, I'm always like, ooh, I'm going to go here. I'm going to go here. I'm going to look at this city. So this is my favorite data structure so far. So yeah, please check out this cheat sheet if you're going to be coding at home. This is a little bit more fun to work with, and you can also, use your own cities in your own locations to get a feel for it. It helps if you're near like mountains or a waterway, so you can actually avoid those locations when you're working with Geosearch. And also check out our Geospatial explainer video. Also covers a lot of the commands that we ran here. So yeah, Geospatial in a nutshell, in a little under 30 minutes. Hope that was interesting.
Definitely, and I'm with you. I really love maps as well, and I don't think it's purely because I've got a really bad sense of direction. So if I go anywhere, I always get lost without fail. I always need a map, but I love an aerial view. I love looking at the shape of everything, and yeah, like you say, sometimes the shape of everything thwarts your mission for copy, doesn't it? Because if you go on a map on your phone, then you might see one that's 3 miles away, but like you say, you've got to swim across the bay to go get it in San Francisco, which is not very useful. No. But yeah, I think this is something that people can definitely play around with and do some practical applications with, stuff that is actually meaningful to them on this course. So this is a really easy thing to just try out on your own data, isn't it?
Oh yeah, and this is used in many different companies. I was actually watching yesterday. I'll see if I can find the video. But there was a great video in one of our Redis conferences of Lyft and how they actually Lyft is a rideshare program in the United States. Lyft, how they use the Redis geospatial indexing, and it was very interesting. And it's not it wasn't just some light, like, oh, this is how I actually implemented it. It's like, no, they really broke it down, and they made it very fast with a lot of different data structures that Redis use. So I would definitely recommend checking that out if you can.
Yeah, and that's the thing. If time is money, and you're telling somebody, I can get you there really fast because it's only 3 miles away, but actually there's no bridge, then you've made a little bit of a mistake there. So being able to map it out properly and actually choose the parameters of where you're searching is definitely useful. Or if like there's a mountain in the way, sometimes you've got to go around it. Like there's not necessarily a way through, is there?
Yeah, if you're walking or if you're on a bike and there's a huge hill or like a huge building you have to walk around, it's like, ooh.
Yeah. Cool. Okay, so that was Geospatial. I think that was a really nice class to end on, actually, because it was super easy to understand. It was only one concept, I guess, and yeah, just a nice, neat little package to end the stream on. So that's cool. Yeah. So shall we have a look at some homework for this week and then look at the exam? Because folks who want to close out this cohort with me need to be thinking about doing the exam very soon. Otherwise, they're going to have to wait until the next cohort and join that if they haven't reached the 65%. So I'm going to share my screen. Right, so we'll start off with the progress. So this is the progress that I've made already. And as all of you good people can see, I've met the 65% pass rate, but I've kind of just squeaked it at 76%. And like we said last week, don't do it by the skin of your teeth, even though Spot the piranha loves the feel of skin on his teeth. Don't be like Spot. So make sure you do all the homework and all the exams to make sure that you have given yourself the best chance of totally smashing that 65% target. So that's my progress at the moment. But because I have met the 65%, I can actually request a certificate. So I'll show you what that looks like now. If you press request certificate, then the button will change to view certificate. And there, you won't get one with my name on.
Hooray! Congrats!
Well, Justin, all credit goes to you for teaching me this stuff. Yeah, you won't get one with my name on. You will get one with your name on, or whatever name you registered with. So make sure you've actually used the name that you want to use. And then you can add it to LinkedIn. I'll show you that at the end. But yeah, so you can get your certificate that way, which is super cool. So that's my progress. Let's have a look at the homework for this week. I have done most of it, but I left a couple of questions for all of us to work through together. So 5.2, what data types does Redis use to store geospatial objects? Now it says data types, but it's a radio button. So I'm guessing it's one of these. It's not one or more, and it doesn't say it's one or more. So we're going to go with one.
Yeah, it's definitely one. That was a bit of a typo, I think.
Yeah, I think so. Yeah. So what is a little bit tricky about this question is that we have the term Geo Hash. So that you may be thinking hash, Geo Hash, maybe it's a hash, but it is actually a sorted set, because you've got the name of the place and then you've got all the different attributes related to it, and you can sort it by score and all of that good stuff and get the distances and find out which ones are nearest and furthest. And you wouldn't be able to do that unless you were able to sort them in some way. So I very confidently declared that it was sorted set there, but you may differ, Justin.
No, you're right on. Yeah, and if you were watching previously, you noticed that we were using commands like z card to check the cardinality. Z, or that is for our sorted set data type within Redis. And yeah, the latitude and longitude are combined to create the Geo Hash value, which is further converted into an integer, which gives us the score for a sorted set. And associated with the score is a member name, which would be like a name of the city in our case, or whatever you want. So yeah, sorted set's the way to go.
Yeah, and always remember, you can press the show answer button to get the explanation as well. Okay, so 5.3 then. Redis does not provide a geodel or equivalent command. What command should you use to remove a single geospatial object for a key holding many geospatial objects? Now, Justin has given us a bit of a clue. If we know the data type, then the good thing about Redis is that the commands are very much, the way that they're laid out and spelt really very much links back to the data type. I've worded that really badly there. But for a sorted set, the commands generally start with a Z or a Z. We did have this conversation a while ago. So because there's only one there with a Z or a Z, my money's on that one. I have got 3 attempts, however, which is quite generous actually, considering there's only one answer that you have to pick. So let's go through them. So Del, I don't think so. I don't think I can't even remember seeing any Dels on its own. HDel, well, that indicates to me that it's going to be a hash.
Yes.
Unlink, well, you wanted to remove, you're not just wanting to unlink, and also that hasn't got a Z. ZREM, yes, I think so. And then none. I mean, what kind of database have you got where you can throw things in and never take them out?
That's a very durable database.
Yeah, have you got unlimited amounts of money to be storing all this stuff? So yeah, I'm going to use one of my 3 attempts on ZREM there and see what gives. Correct.
Nice. Yeah, this one is a little subtle too. If we can actually use del or unlink, but that will completely make it unavailable the entire geospatial index. So it didn't actually ask for that specifically in the question. It wanted to know, how do you remove a single geospatial object or a city, something like that, but in our case. So zrem removes a member of a sorted set. So it's a very fine tweezer command versus del or unlink, which will just completely remove the entire thing. So good call.
Yeah, and that is also a good lesson in read the question.
Yes.
Don't just say remove. Oh yeah.
Yeah.
Dead rare.
Yeah. You have infinite tries to reread the question, but only 3 to actually answer the question. So
Yeah, exactly. So it's the key thing there is single. Okay, right. So that is all the homework for all of the 5 weeks, and you're graded on the homework and the exams. So let's have a look at the exams, and we did have a look at these at the very beginning, and we all agreed and concluded that the quizzes look exactly the same as the homework, look exactly the same as the exam. So please do not be scared of the exam. An exam's open book. You can save your progress, come back whenever you need to. You can go and look things up, etc., etc. And I recommend that you do that because the exam covers the whole course. So whereas the quizzes just covered the couple of videos that you might have watched just now, the exam covers everything. So you're going to need more time to actually think about it because you're going to have to go back to week 1 or week 1 in your brain and think, right, okay, I learned that a long time ago. Let's go back, and it will all be mixed in together. So yeah, definitely take advantage of the fact that you have as much time until the end of the course, and you can go away and come back. You don't have to do it in one sitting. So let's have a look at question 1.3 on the exam. So in the sample data in the virtual lab, there are 2 geospatial keys. So coincidentally, this is about geospatial. It's
nice.
actually it's actually in the first part of the exam, which only goes to prove what I just said about it's all in a mixed up order. So yeah. Geo events, football and geo events, athletics. If you need to find geospatial points that are in both keys, what command should you use? Right.
Ooh, this is a good one.
This is a good one. So the geospatials are sorted sets, as we discussed. So I think it's not going to be S anything because they are just sets. So we're left with Z interstore or none. Geospatial commands only operate on a single key. Now, I don't think they do operate on a single key because otherwise what's the point of having sorted sets and being able to look at the intersection and the difference and stuff? Like, that just doesn't make sense to me. So I'm going to go with Zinterstore or Z interstore.
Yeah, great. This is an interesting one, and I kind of hinted to this, but I didn't actually talk about it. But yeah, so we know that geospatial indexes are sorted sets, and I said you can run some of these commands, but with slightly surprising results. If you intersect geospatial indices, you'll still get everything back, but your score is going to be combined. So your coordinates will be combined, which is not at all what you want unless you run the min-max optional command with Z interstore. And that's actually covered, I do believe, with Alvin. If not, then in the readings. So yeah, specific geospatial commands will not operate on multiple keys, only one key. But you can also use the subset of sorted set commands on geospatials. So there you go. Nice.
Yeah. Cool. So yeah, the explanation, we won't go through that completely, but yeah, the explanation is there.
Oh, cool. Perfect.
Cool. Right. So 1.6. If an exploration of a key is set as follows, code block, what does the following command return? The seconds remaining until the key expires, timestamp when the key expires, the milliseconds until the key expires. So I don't think it's the timestamp because it says TTL, so that's time to something. So I think it would have some element of UTC in there if it was the timestamp. So it's either going to be seconds or milliseconds.
Oh, we got a hint.
Time to live. Yeah. Headmaster of Redis, you gave us a hint. Thanks, Simon. Simon's in the background again, pressing all the buttons. Yes, so I think it's seconds or milliseconds, and I think milliseconds is just could be such a huge number that it's more practical to say seconds. That is my non-programmatic view on the situation.
That's actually a pretty good code fields that you have. That's correct. That's a big number that we're looking at, but sometimes you don't want keys to expire for quite a while. So milliseconds, that's 1,000 milliseconds in a second. So that's not going to last very long. But seconds, yeah. And all of our commands for expire at without any extra options. You can choose milliseconds, I believe, in some of our commands, but they all default to seconds. And we use that for caching, session stores, things like that. So we want it in seconds.
Yeah.
Yeah. There we go. PTTL will give you in milliseconds.
PTTL will give you in milliseconds. Yeah. Yeah. Cool. Okay. So now we've got example 2.4. Once a multi-command has been executed by a client, how many more multi-commands can be executed by the same client before an exec or discard is called? Right. So this is about pub and sub, I think.
This is when we were we were trading toys. So we were giving Spot a cherry tomato, and we were giving Josephine, my chicken, the flower pot.
Yeah, yeah. So you queue up all your commands, you can execute them, or you can discard them. Right. So it feels a bit arbitrary to say one of them can be executed by the same client. And also, as I recall, once you've started executing, all of these commands are in a block, so you can't split them out.
Right.
So one doesn't smell right to me, because why would it be that seems arbitrary? You could have millions in there. Why would it just do the next one? One or more, yeah, I don't know. And then more than one, again, is all a little bit vague. So because they're all in a block, I'm going to say 0.
Yeah, I like that one too. Yeah, because it's all in a block and it all runs sequentially no matter what, multiple multis commands just wouldn't make sense, since you want everything within a multi-exec block to run. So excellent deduction.
Yeah, yeah. Please do not deduce everything. Anyone who's watching and doing the exam, please do go back and look through the material. I'm just deducing for the sake of time, because if we were sitting here doing all these questions in real time, then yeah, we'd be here all night. But since I've already got past the 65, I feel quite safe in doing this little exercise with Justin here. So for field in a hash, how would you decrement the value by 1? Now, let's remember our good friend and colleague, Guy. What's his favourite command? Or favourite village?
The great village of Hinkerby.
The great village of Hinkerby. So, I think, okay, the first one is we can throw that in the bin straight away. It's not possible. Like, what sort of database doesn't let you do that?
Right.
H Deckerby key field 1. This, yeah, it could be H decrement by key field 1, or it could be Hinkerby key field -1. But I don't remember there being a Deckerby. It doesn't ring a faint bell.
No. Yeah, this is a little subtlety. So we have with strings, we have Inker or Inkerby or Inkerby, and then with strings we have decker or decker B, decrement. But with hashes, we don't have H inker. We do have H inker B, but we do not have H decker, and we don't have H decker B.
Wow.
So you have to actually, it's always good to have your references and your commands near you for checking. But you can always go to the terminal and check. Is there an H decker B? No, there's not. So we only have H inker B for hash commands.
Yeah. Okay. So that explains why decker B looks familiar, but H decker B didn't.
Yeah.
Because I've seen decker B before in other data types. Yeah, that was a bit of a trap. But like Justin said, if you go back to the lesson, you will find a link to the web page with the commands on for that data type, and just go and look down that list of commands. So yeah, there's no reason really why you should allow yourself to get stressed about this question. Just kind of breathe and think, right, okay, where is a good place that I can actually go and look this stuff up? So,
absolutely.
Yeah, cool. Okay, so now that's exam part 2 finished. Let's quickly do exam part 3. So, when can a watch command be executed by a client? So we talked about transactions earlier, because we talked about once you've done a multi and then you've executed it, which ones can you remove? So we are kind of already in the right frame of mind for this. So a watch gives you a snapshot in time of the situation before you, at the point where you watch it and before you execute the client, in case there's any changes that you don't want in there when you actually execute your transaction. So you're not going to watch during the transaction, because the point of it is you want to have that snapshot beforehand. So you want to watch, then you want to do your multi-command. Do you want it before your exec command?
Well, you will do it before your exec command, but we've established that you don't want it after your multi-command.
Right. So we're going to eliminate that one, because we want to watch before we do the multi. So we don't even need to. I don't even know why I bothered reading the second and third options. Right. So we want to watch, then we want to do the multi. So the answer is the first one.
Yeah. This is a good one. We always watch the keys before we actually run the sequential actions on them, because if it's like, oh, somebody incremented it, I'm out, I'm not doing it. We want to make sure that everything is on the up and up before we actually run our transactions.
Yeah, I mean, that guy Royce, I really love the guy, but sometimes he just comes along with his hinkerbees and like, hang on, I'm watching this thing. So, yes, yeah. Okay, good. Right, that was a good lesson in elimination again. I seem to be the queen of elimination here. Cool. Right, so let's do the last question here that's outstanding. Can UTF-8 data be stored and retrieved with a string data type without any loss or corruption of the data? Right, so I'm thinking back to, this is going back to, I think, to week 1, when we went through the very basics of the data types. And I remember that we can store all types of data, including like images and stuff. So what would be the point of storing your data and then letting it get all corrupted up and lost, is my logic here. So I want to say yes, you can, because I've got faith in this tool. What do you reckon?
Yes, I would agree with you. So yeah, if you have UTF-8, the encoding defaults to UTF-8, so everything is preserved.
Cool. Okay. Yeah, my logic there I think was questionable, but always is. It's fine.
The main thing that I like to remember is that strings in Redis are binary safe. So like you see here, strings in Redis are a binary safe sequence of bytes. So you can pretty safely store everything you want within a string. And then you can, of course, decode them as well if need be afterwards.
Yeah. Cool. Okay. Right. I'm going to unshare my screen and then I'm going to reshare my screen. So we already had a look at my progress, and I've only just got my certificate live on Twitch. And we're finishing at the top of the hour today, so we're not going to go through the process of adding it to LinkedIn. But what I will do is I will show you what it looks like on LinkedIn, and I will record a video to demonstrate how to add your certificate to LinkedIn. So this is Simon Prickett, who we mentioned earlier, who is the headmaster of Redis University, and also the producer of these live streams. So thanks, Simon, for doing all that behind the scenes button pressing. Simon has been at Redis for nearly 3 years, so he has got all the certificates. And so he is a really good profile to look at on LinkedIn if you want to see all of the good stuff on there. He's also worked at a lot of places before he worked at Redis. So if you scroll down to licenses and certifications, this is where you can put your certificate. Let's see, if I click on this, I wonder if it will actually work this time. Yeah, there you go. So what you can do, I'll go back to the LinkedIn profile. If you go on the LinkedIn profile, you can add in the unique ID that we give you at Redis University once you've claimed your certificate. You can go to LinkedIn and you can plug that in. Like I said, I'll make a video about this, so it's easy to follow. And then it will appear under licenses and certifications on here. And then anybody who wants to check out that certificate can press cease credentials. So for example, you're looking for a job, your hiring manager or the recruiter wants to see, all your certificates. They can click on see credential, and then they will be able to see a copy of the certificate that was issued by Redis University to you. And then there's a link there where they can verify the authenticity as well if they want to. But this is a really nice way of neatly getting all of your Redis U certification onto your profile in a nice, consistent way. So you're not having to think about what was the title of that course again? I think it was Intro to Redis. No, it's actually Introduction to Redis Data Structures and stuff like that. So it's just a really neat way of doing it, very little effort from you, and also allows people to see a sort of a standardized set of questions that you have gone through. So anyone who's looking at that certificate can then go to Redis University and see what course you actually did and what was involved in that. And then they can more easily compare you against other candidates and what they're looking for in the people that they want to hire, what the gaps are in their team. So as you can see, Simon's done all of them. There's 8 courses at the moment. And we're looking at what else we can do at Redis University in terms of learning and events and stuff like that. If you have got any ideas about what you'd like to see, please come to Discord and tell us. But yeah, you can add all your courses on there. All of these courses are running all the time. It's just a case of at what point in the course you're joining. So the current cohort of all of these courses had already started. It's about a week or 2 in. So all the dates on university.redis.com. So go and have a look on there to find out. If you want the full 6 weeks, find out when the next one starts. Otherwise, just go ahead and enroll and start now. So yeah, that is basically your reward for passing your course. So yeah, we'd really love to see if you do get a certificate on RU101 with us, then please tweet it. You can mention me and Justin if you want. Depends on what you think that we helped you. But yeah, definitely do that and give us a shout out on LinkedIn too if you like. That would be really cool. It's always nice to see when people are successful at learning Redis. Cool. Okay, well, we've come to the top of the hour now. I think that was really neat, actually.
Yeah.
We've managed to finish on time today. So, yeah, thanks again, Justin, for this. Like, it's been so good working with you on this project.
Absolutely. I'm looking forward to possibly working on new classes with you.
Yeah, no, likewise. And it's just been really fun for me because I'm new to the company and I haven't really worked with anyone on anything yet, really. So this is kind of my first thing and also my first time streaming too. And also because we're remote, it's, you know, we don't sit next to each other in an office, so you can't really chat. So it's just been really nice getting to know you a bit more on these streams. And yeah, you've been so patient with me and the way you've explained things and spent so much time developing these cheat sheets as well, because that was extra work too, and looking up, you know, some really cool data sets that we can use to illustrate. It's just been a lot of fun.
Thank you. I mean, what's work if it's not fun? Not
Well,
fun.
yeah, exactly. No, I completely agree. So yeah, I think that's everything, isn't it?
Yeah. That was
Cool.
101.
Well, yeah, that's 101. It's done. Yeah, I will go ahead and add my thing to LinkedIn. Look out for a video from me very soon about how to do that. But yeah, until we see you again, look after yourselves, everyone.
All
Take
right.
care.
Take care.
Bye.
See ya.